Now President Biden has introduced the first image to be shown publicly from the James Webb Telescope, the largest and most powerful ever launched into space. NASA's James Webb Space Telescope has barely begun its mission but has already revealed cosmic riddles. Among them is Oumuamua, the first known interstellar visitor to our solar system. As the James Webb Space Telescope catches its first true image, Oumuamua's origin might point to extraterrestrial life. What might this revelation imply for humanity's knowledge of the universe? Join us as we uncover the startling secrets of Oumuamua, which may question everything we thought we knew about the universe. The first known interstellar object to pass our solar system, Oumuamua, captivated the globe in 2017. Unlike anything else seen, the Pan-STARRS Observatory identified Oumuamua, challenging accepted theories and sparking intense scientific discussion. This mysterious visitor generated more questions than answers, and its peculiarities have added to the enigmas of its source and character. The fact that Oumuamua's source is unknown adds one of the most fascinating elements. Although it arrived at our solar system via Lyra's constellation, the precise location of its parent star system is yet unclear. The amazing speed of the object relative to the Sun suggests that it is quite improbable to have started within our solar system. Rather, if not billions of years before it arrived, it might have been traveling the galaxy for millions of years. The exact flight and origin of Oumuamua are yet unknown, since the stars it might have interacted with have since moved from their original locations, making stellar homes difficult to identify. The object's approach from above the ecliptic plane, the approximate plane in which most planets and interstellar objects revolve, complicates the situation even more. Because of its odd trajectory, Oumuamua did not come into close contact with any of our solar system's main planets, leading scientists to speculate that its trip through space was largely unobstructed. Researchers utilized data from the European Space Agency's Gaia spacecraft to try to trace Oumuamua's path, suggesting that it could have come from one of many nearby star systems. These include the red dwarf star H3757, the sunlight star HD 29224, and two additional stars with less familiar names. Despite these efforts, the object's exact origin remains a mystery. Another riddle of Oumuamua is its physical appearance. While several artistic depictions have been developed, there is no conclusive image of what it looks like. Observations have indicated that Oumuamua looks to be elongated, approximately 10 times longer than its breadth, which is exceedingly uncommon in comparison to other known interstellar objects. Most comets and asteroids have a length-to-width ratio of approximately 1 to 3. Its brightness changed by a factor of 10 every 8 hours, indicating great elongation and rapid tumbling motion. As Oumuamua moved through space, it seemed to be a flashing light due to the tumbling action. Unfortunately, because the item was only visible for a short time, scientists have yet to obtain a detailed image of it. Adding to the enigma, Oumuamua experienced an unexpected acceleration as it approached the Sun. Observations from the Hubble Space Telescope and other ground-based observatories revealed that its speed increased somewhat, modifying the anticipated course. This acceleration could be explained by outgassing, which occurs when gas and dust are released from an object's surface, as seen on numerous comets. No direct evidence of outgassing was found with Oumuamua. Some scientists believe that the acceleration is caused by gas jets or the sublimation of strained materials such as solid hydrogen or nitrogen ice. However, these theories are speculative. Oumuamua's journey was brief. It went through our solar system and is presently accelerating away at about 26 kilometers per second. The asteroid is anticipated to leave our solar system after more than 20,000 years, which is a mere blink in galactic terms. The short observation window and the object's fast velocity provide substantial obstacles for future research. Voyager 1, the fastest spacecraft ever launched, travels at 16.6 kilometers per second, making catching up with Oumuamua using current technology implausible. Even advanced concepts like laser propulsion and solar sails would struggle to achieve it. The peculiar properties of Oumuamua have sparked a variety of ideas concerning its origins. One possibility is that Oumuamua is a fragment of a bigger celestial body, such as a planet or moon, that was ejected from its host star system during a near collision with another star. This idea proposes that Oumuamua may have spent millions or billions of years drifting across interstellar space before colliding with our solar system. Another idea holds that Oumuamua was part of a larger object destroyed by tidal forces as it approached a star, which explains its elongated shape. AVI-Lab, an astrophysicist, proposes a more unusual theory. Oumuamua could be an example of alien technology. Lab has suggested that the object's unusual shape and behavior could be best explained by an artificial origin. He speculates that Oumuamua could be a solar sail or a component of a Dyson sphere, a speculative structure designed to extract energy from a star. According to Lab, such a thing would need advanced technology to generate and would contradict our existing knowledge of natural celestial objects. The mystery of Oumuamua continues to captivate scientists and scholars. This interstellar visitor, discovered in October 2017, has become a topic of debate in the astronomical community due to its peculiar properties. With its findings, fresh questions concerning its composition, structure, and possible technological origins have arisen. As scientists attempt to determine the nature of Oumuamua, they are confronted with many possibilities. If the object's composition differs from anything observed in nature, it may indicate that Oumuamua is not a normal celestial body. For example, if its structure matches that of a spacecraft, it indicates that it is more advanced than a simple rock or asteroid. To really understand Oumuamua, detailed information is required, especially if it has any technological traces. AVI-Lab, a leading specialist in this field, has claimed that catching up to Oumuamua with a spacecraft is a tough task. The object's enormous speed, estimated at 315,000 km per hour, 196,000 miles per hour, combined with its trajectory, makes it extremely difficult to intercept. Lab feels that the sheer speed necessary and the immense distances involved make such a mission practically unachievable with current technology. Despite these hurdles, various missions have been proposed to approach Oumuamua. These concepts seek to address the significant challenges of high-speed transport and precision aiming. Existing chemical rockets are insufficient to achieve the speeds required to overtake Oumuamua, but novel ways could be used to accomplish this. One such strategy is to use gravitational slingshots or flybys. This strategy, also known as a gravity assist or O-berth maneuver, uses the gravitational fields of celestial planets such as the Sun or Jupiter to boost the spacecraft's speed. Spacecraft can accelerate significantly by approaching these huge objects and exploiting their gravity. This strategy has been employed effectively on previous missions such as the Voyager probes to propel them to the outer planets. Adam Hibbard, a freelance software developer located in the United Kingdom, has developed potential missions to Oumuamua using his expertise in trajectory optimization. Hibbard, who was already designing software for interplanetary paths, started working on flight plans for Oumuamua after learning about its discovery. He and his Project Lyra team suggested numerous possible mission designs. One option involves deploying a spacecraft in 2030 which might approach Oumuamua in around 22 years. Initially, the crew contemplated missions that involved close encounters to the Sun, which would necessitate massive shielding to protect the spacecraft from extreme heat. This strategy, however, would drastically restrict cargo capacity. As a result, Hibbard and his colleagues began investigating other strategies to avoid such close encounters with the Sun, instead relying on Jupiter's gravitational effect. The scientists discovered two viable approaches for reaching Jupiter from Earth, both of which involved a sequence of slingshot movements around the inner planets. Both methods would allow the spacecraft to achieve enough velocity to use Jupiter's gravity as a slingshot to Oumuamua. These tactics would result in a mission duration of around 31 years, which is 9 years longer than trajectories requiring close solar approaches. Marshall Eubanks, chief scientist at Space Initiatives Incorporated and a member of Project Lyra, is enthusiastic about sending a spacecraft to Oumuamua or other interstellar objects. He points out that while expeditions to nearby stars are being suggested, Oumuamua's closeness will remain far closer than such distant locations. Even after a century, Oumuamua is about 150 astronomical units away, in a century, compared to Proxima Centauris' 4.24 light-years, making it a more accessible target for exploration. Catching up to Oumuamua is technically feasible with current technologies like SpaceX's Falcon Heavy, however, crossing huge distances and determining the exact location of the object present major obstacles. Oumuamua's position is highly unclear, with its current location uncertain to within a distance comparable to that between Earth and the Moon. Finding such a little object in the dark expanse of space would be difficult. One possible approach is to send a scout mission to find Oumuamua before sending a larger spacecraft for closer inspection. This preliminary mission might use a big telescope possibly half the size of the Hubble Space Telescope to examine the sky for Oumuamua. Alternatively, a swarm of tiny spacecraft may be sent to survey a large area. The Breakthrough Starshot project is looking at this approach with the goal of developing technology to deploy swarms of small laser-propelled probes to nearby star systems. These tiny spacecraft might theoretically reach Oumuamua's vicinity relatively quickly and gather important data about its nature. Despite the challenges posed by interstellar travel, Oumuamua has sparked significant interest and excitement among scientists and the general public alike. Its unexpected properties and the possibility of extraterrestrial origins have prompted debates about what constitutes life beyond Earth and the potential for other civilizations in the universe. The enigma surrounding Oumuamua has not only challenged our understanding of celestial bodies but has also reignited discussions about humanity's place in the cosmos. As the James Webb Space Telescope continues to unveil the mysteries of the universe, the search for Oumuamua's origins remains a fascinating journey that could redefine our understanding of interstellar objects and the potential for intelligent life beyond our planet. The potential of discovering extraterrestrial intelligence or understanding the origins of our universe rests on the investigation of Oumuamua, representing the next frontier of space exploration. With upcoming missions and innovative technologies, the scientific community remains optimistic about uncovering the secrets of Oumuamua, ensuring that its legacy will endure in the annals of astronomy.